Physical properties of metals and non-metals. The objective of this session is to make you understand about physical properties of metals and non-metals. Till now we studied in brief about metal and non-metal properties with characteristics. What do you mean by physical property? Properties that can be known without making any chemical changes to the substance are called physical properties. Physical properties of metals are malleability, ductility, good conductors of heat, good conduction of electricity, lustrous, generally hard, generally strong, generally exist as solid state, melting and boiling points are high, high density, sonorous and color. The physical properties of non-metal are non-malleable, non-ductile, brittle, bad conductor of heat and electricity, non-lustrous, generally soft, not strong, exist in three states like solids, liquids, and gaseous states. Melting and boiling points are low, low density, non-sonorous and color. Note that physical properties of metals are completely opposite to physical properties of non-metals. Let us elaborate each physical property with examples. Let's start with malleability. The property which allows metals to get hammered without breaking into thin sheets is called malleability. Examples for the metals which are malleable in nature are gold and silver. Aluminium foils are used for packing like biscuits, chocolates, medicines, cigarettes, etc. Let us learn about ductility. The property which allows metals to be drawn into thin wires is called ductility. Examples for metals ductile in nature are gold is the most ductile metal. A wire of about 2 kilometers length can be drawn from 1 gram of gold. Copper and aluminium metals are also very ductile, which can be drawn into wires that are used in electric wires. Now let us learn about conduction of heat. Metals are good conductors of heat. Examples for metals which are best conductors of heat are silver and copper. Examples for metals which are poor conductors of heat are lead and mercury. Let us do an experiment to show that metals are good conductors of heat and have high melting points. The apparatus required for this experiment are 1 burner, 1 stand, 1 clamp, 1 metal wire, it can be aluminum or copper, and 1 iron pin. To do this experiment, we need only wax. Let us start the experiment. Take an aluminum or copper wire. Clamp this wire to a stand. Fix small iron pin to the wire with the help of wax. Heat the wire with a burner near the place where it is clamped. Observe the change. We observe that after some time, the wax starts melting, and then pin falls down as the heat travels from left end to right end of the wire. If we heat the wire for some more amount of time, then the metal wire starts melting. So, by this we can conclude that metals are good conductors of heat and have high melting points. Now let us observe here the burner placed at left end of wire. So, the left end gets heated first. But the right end is cool. So, heat travels from hotter left end to colder right end. The next physical property of metal is conduction of electricity. Metals are good conductors of electricity due to availability of free electrons. It means metals allow electricity to pass through them easily. Silver and copper are the examples for metals which are good conductors of electricity. When a metal sample is inserted into clips, the bulb glows. This shows that the metal conducts electricity. We prefer using copper more, as silver is an expensive metal. The next physical property of metal is lustrous. The metal having a shining surface property is called metallic luster. Some metals lose their shine when exposed to air for a long time, and acquire a dull appearance with the formation of layer, that is oxide or sulfate, or carbonate on their surface. Bangles made with gold is an example for lustrous metal. Here note that bangles are made up of gold, because it is a highly lustrous and durable, non-corrosive metal. Next is nature of material. It could be hard or soft. Metals are generally hard, except sodium and potassium. Pure gold is not used in making of ornaments, because it is very soft. So, 24-carat pure gold is converted into 22-carat by mixing silver or copper. Examples for nature of material are sodium and potassium. These are soft metals which can be cut with knife. Next physical property of metal is strength of material. Metals are very strong, they can hold weights without snapping, without breaking, except sodium and potassium. They are weak metals. For example, bridge made by steel. Please note that, as iron metal, as steel, is very strong, it is used to build bridges. Let us now look into state of material. In general, all metals are solids at room temperature, except mercury, as it is liquid. Let us now look into melting and boiling points. Metals have high melting and boiling points, except sodium and potassium. They have low melting points, that is 98 degrees centigrade and 64 degrees centigrade. Melting and boiling points of few metals are: gallium and cesium metals have low melting points, of 30 degrees centigrade and 28 degrees centigrade respectively, as they start melting in our hand. Iron has melting point at 1535 degrees centigrade. Copper has melting point at 1083 degrees centigrade. Of all metals in pure form, tungsten has the highest melting point, that is 3422 degrees centigrade. Next is density. Metals have high densities, except sodium and potassium. These metals have low densities. It means that metals are heavy substances. Example, iron density is 7.8 grams per cubic centimeter. Sonorous. Metals are sonorous in nature. It means, when they strike a hard surface they produce sound. It is due to this property of sonorousness, or sonority. That's why metals are used for making bells, and strings, wires, of musical instruments like sitar and violin. Let us see the last physical properties of metals, which is color. Metals usually have a silvery or gray color, except copper and gold. For example, copper is in reddish brown and gold is in yellow color respectively.